Okay, so we are coming back from our coffee break with another technical section 2. Now we're going to talk about core networks. So you're going to have here more three researchers. The first one is Professor Cristiano Bonato from University of Vale dos Sinos. Professor Cristiano has been associate professor at the University of Vale dos Sinos since 2019. Work in the graduate program in applied computing. He's a visiting researcher at Unicamp through the Smartness Engineering Research Center in partnership with Ericsson, and serves as a consultant for RNP in 5G, 6G, and Open RAN. He is also research at Embrapi Inatel Competence Center, focused on 5G and 6G networks. He's actually the project coordinator here at xGMobile. And he is earning his PhD in computer science from the Federal University of Rio Grande do Sul in 2011, with a research stay at University of Pisa, and his master's degree from PUC-Rio in 2003. He coordinated the Innova Center of Excellence in 5G, 6G networks, founded by FINEP. He contributed to the major national research initiatives supported by PAPESP, MCTI, and RNP, including PURV 5G and Brazil 6G Phase 3. He works centers of open and disaggregated networks, Open RAN, virtualization, SDN, and AI-driven networks intelligence. Internationally recognized, he has made significant contributions to the wireless and mobile networks. He is regarded as a leading researcher in the next generation networking techniques, and his talk is going to be about the enhanced 5G core services through Open Gateway. Professor Cristiano, the floor is yours. Thank you.
Thank you, Luciano. Thank you very much. Thank you for the opportunity to present my work, my study, and congratulations for the workshop. Is very nice. My focus today is little different in the other sections, because I don't present now my research, my papers. I presented today my study, my interest in different topics. For example, considering the service in telecommunications. My interest in this topic is how I provide capabilities on the network for the three parts and the other parts for the networks. This is idea in my study, in my presentation now. Luciano told I coordinated one project in the xGMobile. The focus in this project is a Nova Genesis and network slides as a service. I discussed these topics in the third day, in the last sections in the third day. And I investigate in my research computer network, telecommunications, mobile telecommunications, and more or less, and considering, for example, the softwareization. And my background, I use my background for organize these presentations, considering, for example, the new mobile networks capability. This is the idea, how provide the capabilities for the networks, for the other part for the networks. And in this study, I investigate for the story evolution for the 5G core. The focus in my presentations is the core networks only. And we change 6 years ago the architectures, because now we using the one server-based architecture and not one monolithic architectures. Is different, and this architecture provide new opportunities for the network exposure function for the other part for the networks. And I study the associate for the core, the 5G core functionalities, and the Open Gateway interface, considering the GSMA and the camera project. And finally, I showed the two use cases, one considering the open source using the free 5G C core, and the focus is to implement the more functionalities and the update the functionalities considering this search project. And the other, how the Brazilian operator provide this service, this capability in the other parts today. This is my agenda. Look is different for the other presentations in the last sections, because I don't present my research, my papers. I present my view about this service today. Many people talk about the, okay, operators will not survive considering self-only transmission data. I listened this sentence 50 years ago. Okay, self-only bits, transmit bits, it's good, but the telecom operators need to provide other servers. The question is, what servers? How can provide for the other customers, the developers? How do you provide? The operators need to offer new servers. But what servers? What type of the servers we provide for the, for example, V2C, for the edge applications, for the health, for the other networks, for the other business? Is my question for the start the student for the new servers in telecommunications. And I study the history for evolution for the telecommunications. Of course, it's my point of view considering the softwareizations, not the infrastructure for the hardware only. But we have is a very different perspective considering, for example, the first generations. For example, in the first generations, is fortly based on a specific hardware and softwares. The softwares is embedded in a specific hardware. And after the release 15, we change the architectures, because the architecture now is based on the servers, the SBA architectures. And now we use the general proposed hardware and the server-based paradigms. For example, in the first talk in the afternoon, the colleague told about the Kubernetes, the Docker. It's a new tools. We use now new tools. It's a different for the other generations. Is the last generations. It's a new paradigms in the telecommunications. And these paradigms start 6 years ago. And evolution is very faster. This might start the study about the exposure, new capability, and the other servers. My background is in core, for example, and I understood the release 15 provide the new servers considering different functions. For example, we have 2 plans, one the data plan, one the control plan. And now we have many functions in one distribution system. We have, for example, one functions about the specific for the management users, specific functions for the section, for the management sections, specific function for the data plan. We have a specific functions considering different servers or microservers. We have one core considering these perspectives in after 50 15th release. And more recently, they follow the same approach. For example, considering the Open Run Alliance, we have new servers in the run. For example, Michael, in the first talk about the no real-time RIC, the near real-time RIC, no real-time RIC, the SMO, all servers provide, and the other part for the networks. This is a new. We have now one architecture for the run, for the transport and the core, support the new server for these networks and provide for other part for the networks. This is a new. And this configuration provide opportunities for new innovations, new technologies. This opened the telecommunications in the 50 years ago. And the integration for the all functions, for the all server, we have one service-based interface. For communication, all part for the elements, for the components, considering the same machine, the same device or not, or distribution for the networks. We use this now in the research, in the companies. It's not new. But the paradigms has many opportunities to provide the new servers. And this context, I studied about the one new function, the network exposure functions, NEF. NEF is one function for the core to expose the internal capability for the mobile operators. Has new servers for the third part. Okay, I work in one company and I request one research about the operation. I request one data, one information about the one operation. This is a new. But how provide this? How configuration this? How provide this technology, these functionalities? This is the idea in my presentation now. NAV access interface open and standardizations to create new business opportunity for the server's mobile operation. This is a good topic now because I provide new business, new opportunities, considering the softwareization, considering the software-based paradigm. And the benefits for the NAV are also to optimize research allocations. Professor Kleber talked about the research allocation in the next presentations. But what's the new in this research allocation, the optimized research allocations? Because the third part requests one new service, and I need to provide network efficiency, considering the research allocation for the one request for the outside the operator, not inside. This is different. This provides many challenges because we have the security, we have the protection, we have the control, we have the orchestration. We need to think about any topics to provide one optimized research allocation, considering the NAV, consider the one exposure new servers. In my opinion, has many challenges considering these perspectives. And I understood what history for the NAV, what history the NAV considering the open gateway, how the relationship for the core and the open gateway and the camera project. I studied for the release 15 and understood the NAF has three phase. The first phase, the introduction. In the release key 15, NAF has introductions, has one core element, but not many specification, but one introduction for provide security, provide controller, provide the standardization, and define one API, the North API, for the provide access for the application for the NAF. And the intern NAF has oriented event exposure, only event. For example, what event? For example, traffic, quality of servers, authority, policy is very simple in the 6 years ago. And the NAF is a one functions considering the new core, considering the core in the SBA, the service-based architectures. Is important because the integration the NAF and the other cores using the SBE, service-based interface, is native. Okay, in the release 16 and release 17, the 3GPP is propose one expansion for this component. In the first idea is introduce the common API framework. Okay, we have the northbound API, but we have the one function for discover, authority, auditum for the application verticals, because the idea is how third party using this capability. The application verticals, for example, the edge applications, the V2X applications, and the other applications access the infrastructure for the core, and the other components considering the common API function. This the release 15 define the common API framework and define more detail about the southbound API. Okay, probably Kleber, Christian, and the other professors understood, North API, Sound API. Okay, is SDN. Sure, of course. But when the SDN paradigm is used in the telecommunications, in the core, and the release 17, no news about this part, but the new is integrations, the NAF for the north and the south, and the specification more detail concerning the applications, the vertical applications. This is a new in the 2 release, and considering for the 18 and the 19 release is the third phase, is the 5G advanced. The idea now is not more one event only, but the NAF provide one server catalog for provide different servers. It's a one evolution for the release 15, because in release 15 the idea is provide events, only events, not provide one server catalog. This is a new in the release 18 and 19. And new capacity for the use case considering the energy. Okay, it's a hot topic today. But I provide for my telco reduce the energy capacity. What is doing? I provide the resource allocation efficiency, sustainability. IoT advanced, I request, sure, wow. I request many capabilities for the networks. Okay, I first, because I have more 5 minutes only. And NAV work only one telco, not many telcos. And it's associate open gateway for the NAV, because I have many telcos, but I need to integrate the customers, developers, tenants, considering any telcos. For example, one fintech wait to verify the customer authentications, but not the only operator, because I use one, Sandy use the other. We need to check the authentications for the considering the all. Okay, I need the one API open gateway. I need to one API standardization. Its open gateway interface is a GSM global initiative to enable mobile networks to function for the open platform, making telecommunications capability for accessing the capability to the developer new functionalities. The focus is simple integrations, not complex, the simple. The focus is clear, the interface clear for the easy functionalities. Oriented a code using the many format, for example, JSON, for example, easy. Strongly privacy and the controls. This is idea for the one standardization API for the access to different operators. And the practice, I use the Camara project. The Camara project and the GSM working together, because one define the specifications and the Camara project deploy the one example, the one API in the practice. Today we have 10 APIs stable for use, considering, for example, the communication, the connectivity, the identity, the payment, the frauds. We use these parts. We have more one set the APIs not stable in the tests for the we use. In this semester, I teach one lecture for in graduation, and we proposed 2 works. The first works to implement the one API, considering, for example, NAV and Camara project together in the open source. It's the one proposed. And the other proposed, the other student, I proposed, okay, in Brazil, what using the open gateway in Brazil? I showed the two cases. In the first, my student implemented the quality of demand based the free 5GC projects, the open source projects. And the idea the external application can be request on demand quality of servers in the core using the one external API. For that, he implemented the one part and the change and they updated the other part for the core using the Go language and the REST API. And we change or update the PCF, the policy control functions, the SMF, the PCF to support this API. And this part, we integration the NAV and the Camara project KOD API. The idea is request one quality of demand, the NAV request on policy control, PCF associate the policy in the sections for the user, and the PDF deploy the new request and return for the application. This is the idea. It's not easy to implement this part. Okay, it's not many complex, but it's possible in one lecture. My student implemented the request considering the camera projects specifications and received the response considering, for example, the duration time, the type of the quality of demand, and the specification part. Today, my student test and validate for the performance evaluation considered. Probably in the next week, in the finish the lecture, and we show the results considering this perspective. And the last, other student in the class study about the Brazilian operator. Brazil is one pioneer in using the Open Gateway. This is a site of the GSM, and Brazil has many options considering the three big operations provides APIs today. The idea is, okay, the one operator provide the good experience in API or not. My student test three APIs, for example, one number verification, SIM swap, device locations, for to detect the fraud. For example, we send the telephone number, we send the latitude, longitude, and the operator responds, this position is false or true. Has one tolerance, for example, 5 meters, but we check, we receive, this telephone is not true, is not correct, the position now. And the preliminary results, this API for the one provider in Brazil work, it's good, but don't have performance yet. For example, we request many solicitations, many devices, the time is lower. And the servers are still in the testing phase with many opportunities to provide the new APIs and new functionalities. I finish. But today we have 3 operators from Brazil and provide these servers. But in the first phase, in the preliminary phase, other point, this part is the bureaucracy. Is we need to assign one term. Is not one server. The simple access is complex to us access because the service is not provide one good infrastructure for the security, the controller, and the payment. The preliminary results about the performance evaluations we receive the next week, and probably we dissemination in one short paper. I don't know exactly, but probably we show the results for the 2 use case in one publish. I don't know exactly. And the last, I present one tutorial in the 3rd day here in the last sections, and I invite you for join. In the tutorial 3, I in my postdoc show about the from static slicing to network slicing as a servers, the evolution for the 5G network customized. Okay, in the last sessions, but not less important, in my opinion. Thank you, Luciano.
Thank you, Professor Christian. We do have time for one fast question. Don't be shy.
Hello, thank you for a nice presentation. Because this API is open source, and what's the security challenge in this API open source? How you overcome the security issues?
It's a good question because we provide many capability, functionality considering for the telecommunications, but we don't have lunch free. The security and the performance is a good challenge. And specifically the open source project, the Free5GC, in my opinion, the methodology for the Free5GC is not good in performance evaluations. But the Free5GC normally is the first project open source for the provide the one solutions. We have the other projects, for example, the Open5GS is more robust for the security, the control, and the other issues. But depend for the strategy. For example, what is your strategy for the first? You provide the solution in the first for the world, or you provide in the second time or the third time for more robust solutions. Depending on your strategy for your company.
Thank you.
Thank you, Professor Cristiano. Okay, I'm sorry.
Hi, Cristiano. Very good presentation, and I would like to know why do you think that the performance issues? How do you explain the performance issue? Is it because the core NEF? I mean, do you know where NEF was positioning? Is it in the core network, or it was in any edge core? I mean, because maybe depending on how many sorry, but depending on the distance where the function is located, you can maybe you are having this performance issue because of the positioning of the function. Do you know where the function was?
The performance evaluation is a hot topic in our issues. I don't know specific the metrics for the NEF because probably the 3GPP not define the exactly range for the metrics for our functions, but the open gateway, the GSM, define one specific metrics for the performance. For example, the latency, one request for the latency not pass for the 2 seconds. The confiability 9 to 99%. The GSMA define the specific parameters for the performance evaluations, considering the open gate and API, not the NEF. The NEF, I don't know.
Okay, thank you.
Thank you, Professor Cristiano. Let's applaud him once again. So we're moving to our next presentation. which is going to be delivered by Professor Christian Esteve Rothenberg. Professor Christian is an associate professor and head of the Information Network Technology Research Innovation Group in TRIG at the School of Electrical and Computer Engineering at Unicamp. He received his PhD in Electrical and Computer Engineering from Unicamp in 2010. He holds telecommunication engineering degree from Technical University of Madrid and a master degree in electrical engineering and information technology from Darmstadt University of Technology in Germany. Dr. Rothenberg has contributed to multiple international patents, co-authored 3 books, and published over 200 scientific works in leading venues such as SINCOM and InfoCom. His research accumulated over 13,000 citations, and he has a H index above 40 and the I-10 index above 100. Since 2023, he has served as principal investigator at the FAPEP's Engineering Research Center, Smartness, and which was co-founded by Ericsson and expected to run through 2033. His work reflects a strong and sustained impact in computer networks, software-defined networks, and future communication systems. His talk is about engineering for the unknown, open source and 6G experimentation toolbox for protocol innovation and high-fidelity testbed evaluation. Professor Christian, welcome. The floor is yours.
Thank you, Luciano. Congrats for the organization of the event. Thank you, everyone, for being here today. I wish I would have more time to talk more about what smartness is doing towards 6G. As I was happy that Luciano cited our work. We have many work packages, but the work that I have selected for you today, I think that fits best is the spirit of the workshop is what we are doing towards enabling experiments, okay, realistic experiments in 6G. And it was also well put today that we don't know actually what is. It's unknown what will be 6G. We just saw Cristiano mentioning the evolving standards, the APIs. So which headers, which protocol, that we don't know. So that's behind the spirit of what we have been doing for a number of years, and what I will present you today. I will introduce some of the well-known challenges of existing testbeds. Then I will go through the toolbox. There are a set of open source but hardware-based platforms. One of them mainly for emulating networks, and 2 which are 2 generations of traffic generators that we call PPOTG and P4R. Then a couple of use cases where you can see them in practice, some future directions, and some comments around community and impact. Okay, so it's uncertain what 6G will look like effectively. Standardization is about to begin, research is ongoing. There are many moving parts. The protocol stack that will make it to the standard will be defined. The headers may be moving, but there may be new ones, new abstractions. We listened today also very brilliantly to Ian's talk about semantic communications, and we don't know whether these new applications will introduce changes in the core, in the functions, in the telemetry to realize these AI native architectures. What we only know is that we don't know, and that's the spirit of how we were building these platforms for evolving needs. Okay. So today you can build your platform based on different types of technologies. You may use SDR for some 5G type of implementations, or rely on software-based or even commercial pieces, but it's hard to test new headers, new use cases, integrate telemetry, or have workloads, so real applications running over your testbed. And even harder is to have a relevant congestion patterns, background traffic generation, we found that it was also a very interesting feature to have in your testbed, because at the end you want to stress your rig, your controllers, your algorithms, the effect on the foreground application. But there is no stress if there is no competing workload that is realistic. Okay? And running iPerf on the background is not realistic for an access network. Okay? So unrealistic workloads, accessible, you don't have the budget, the cost to build a big testbed, and it gets outdated very soon. And also knowledge, even if we get all the pieces to have the right students in time to build the component test, to put together everything, the knowledge limitation, the access to knowledge is also another restriction that I'm highlighting here as well as a challenge that all of us face. Then we have the traditional trade-offs that I don't need to explain to any in this room, between choosing a simulator or an emulator or building an actual testbed. You know the trade-offs: fidelity, cost, realism. We have gone through this, like many in the field, with the Mininet Wi-Fi experience. And this is the picture that summarizes our toolbox, okay? That starts with building a high fidelity, high speed, high capacity emulation of networks. It's basically a testbed on a chip, on a Tofino chip, what we have been working on. And now that we have an emulated topology, we need the traffic. We need realistic traffic. We want also to have realistic background, relevant. And these are the two tools that generate traffic. And that traffic can be built also from traces, from real traces, that either affect the parameters the way these generators generate traffic, or that really put the actual captures, the pickup files, into your production network and replay them. And I'm sorry that Ian is not here today, because he pointed to the data augmentation opportunities or trends when you have small data sets of relevant traffic, and then you want generative AI techniques to build more of that traffic that is relevant. And this is another trend that I'm not touching today, about generating traces that are realistic, meaningful, and useful for your research. Okay, so everything started in spirit of Mininet. I was a fan of Mininet when I was doing my PhD, when I had the opportunity to spin different topologies quickly. And since then, I went to extensions to the Wi-Fi. And naturally, after working with P4 and programmable switches, we came together with RMP, that must be sent with Marco Schwartz, Fabrizio, to the idea of why don't we try to build this type of technology, of this type of abstraction of a topology inside the Tofino. Okay, so we can build topologies and then have real traffic. And that's where the P7, the P4 programmable patch panel came. So no classes today, but let me check. Who knows what is P4 in this room? P4, don't be shy. 1, 2, 3, 4. Okay, less than 20% of the audience. Okay, I will need to keep it very simple, but you know that switches, routers, and boxes are usually built in hardware. This hardware has been designed by fixed functions, and the functions that the hardware supports are written, and there is a driver that your operating system installs and allows you to communicate, okay? So from the fixed functions, you build your software. The programmable switch paradigm builds upon a programmable chipset. You can think also as FPGAs, but it's an ASIC designed specifically for the networking domain. And the idea is that before you use it, you are able to program, to reconfigure it in a convenient way. And the convenient way, the convenient programming language, it's P4. It's the best one that we have. It builds from definitions of headers and a set of tables with match and action capabilities. Okay, it's a very small, reduced C language without loops, and if you want to see it like that. Okay, but what matters is that it allows you to define headers, packet fields, sizes, actions before or even at runtime, and then you compile it, you reconfigure your hardware, and then your hardware will understand the packets the way you told it. And then at runtime, you have your control plane populating the entries of these tables. That's the shortest class in P4 that I've tried so far. Okay, so we started this idea, as I mentioned, 2022. So it's around 5 years when we started with these folks, with Marcos, with Fabricio. We love demos, so we started right away with a demo in SIGCOMM and got even a prize. And the idea, without going into further details, is that the switch ASIC, the chip, becomes a network. It becomes your testbed. Okay, so you can define a topology with some properties, jitter, packet loss, latency, connectivity. And this is how the internal pipeline is configured. And then you have another pipeline when you can also add custom P4 code per node. Then you can think, this node is an access network node, this node is an UPF, or this node is whatever you want in your experiment. Not whatever, because not everything will be able to compile, especially if it's stateful and it uses resources that, of course, are constrained within the size of the chipset. Okay, these are details about how it's used, the topology definition, and other inputs, and then the P7 code ends up producing all the artifacts from configuration down to the object that goes and configures the actual hardware. Okay. Good. So this could be a toy example of what you could build. And then the interfaces are real. You attach your real ports. And every of these links can have different properties, even dynamically can be changed. Okay. But now we had the topology, and that was a real problem. We had a 32 100 gig port switch, but we didn't have even a 100 gig interface card. So we could not put traffic into our topology. So we bought the 4 by 25 gig split DAC cables. We had 25 gig interfaces. So we started being able to inject some traffic, but just 25 gig and just from this type of DAC tables. And we only had one of these smart NICs at the time. So we started investigating how these Tofino switches, these Tofino ASICs, can be also used for generating traffic at line traits and programmatically with programmatic properties, headers. Okay, that was the question, and that's where this high performance parameterizable traffic generator started. And don't look PIPO or PIPO into the acronym, because PIPO is sitting there. Filippo, you can raise your hand. So that's Filippo's undergrad work at Unipampa with Marcelo, who started this. So there's no magic in the acronym. It's just people from Filippo, okay? And Filippo is over there. So any question, you should take the opportunity to take to Filippo. But the motivation, again, is clear. You want good traffic generators. Good traffic generators with all the properties are very expensive, commercial ones. Software traffic generators are limited in performance, in accuracy, in time sensitivity. Okay, hardware traditional are hard to program, problems of cost, okay? At the time, there were other smart folks in Germany doing similar things, which it's always a good idea when you are not the first, but you are among the first, like Ian said. Maybe you are not so wrong in trying to combine some things. And of course, never two folks come the same way to the same solution. Sometimes you have some advantages, and sometimes you can learn from others. So that's what we have been doing. It's also very high level, easy to program, to define. You can recognize easy scriptable, mininet-like Python code, throughput, the IPs, IP addresses, output ports, okay? Again, same experience, the user defines, and then the framework produces all the configuration for the switches to exercise what you have defined, okay? These are examples of patterns that you can build, throughputs, waves, burst, denial of services type of attacks. All of these can be scripted, and your Tofino box will output at these rates with very high precision these types of patterns, okay? So you can craft your own packets, you can define the pattern of the throughput behavior, use the standard protocols or build new ones. That's where the flexibility towards 6G, encapsulation, telemetry formats that are not yet defined will be supported. And you can even put some of your user P4 code along with too, so that the packets go through some of your user P4 code before they exit. But not fully satisfied, Francisco wanted to do more together with Fabrizio. They were already messing up with TCP connections directly inside the ASIC, changing the sequence numbers for doing, at the end, manning the middle attacks. And they evolved these traffic generation capabilities to be able to be clients, act as clients and servers of TCP endpoints, and even to reproduce real packet traces. That's the next generation that's called P4 replay that is able for acting as a TCP endpoint, and also to input pickup traces. So you have these three types of modes. You have your switch can be a client starting TCP connections and closing them, of course, reacting, or receiving, responding to TCP connections requests, or even in an internal mode, you have on one pipe your P4 logic, and on the other, the traffic generation. So you generate the traffic, test it, and receive it back. So this is a visualization. You have your pickup, you capture in the field or wherever you got the packet capture. You can choose to reproduce it originally with the same inter-packet arrival times described in the pickup file with the high accuracy that the Tofino box gives you, the nanosecond level precision, or you can accelerate and try and push them. You can mess whatever you want with the timestamps and produce other higher throughput sessions. And on the stateful connection mode, you can spin over one port, multiple connections or different targets over different ports. All of this is possible with the programmability of the Tofino that gets easy through what we have built, okay? The Tofino gives you the low-level properties, and we build this middleware, this framework to facilitate, okay? And then which packets traces to reproduce. And the other, this is for another talk. This is how to use generative AI for realistic trace generation, maybe another day. Today, I need to talk to you about use cases so that you can see these tools in action, okay? I've selected a couple of ones. One that needs to be highlighted is towards 6G. And we know towards 6G that time fidelity, supporting time-sensitive networking protocols like DEDNet, industrial use cases where Ethernet, statistical Ethernet is not sufficient. There are many new protocols and standards, and they are hard to test with precision, and that's where we built, let's call like a fork of the traffic generation. Sergio is also there. Sergio has worked on this, the time-sensitive networking, and there are still a couple of extensions to be done. So if you're interested in time-sensitive networking protocols, we have this work in progress. This is another use case that is noteworthy for 6G. You know, there are so many of these EU projects doing EU 6G research within the SNS framework. I came across this one, deterministic 6G, and they were capturing traces of ultra reliable, low latency 5G standalone private network for robotic arm control. And what they did is they observed the delay distribution of interpacket gaps in this type of use case. And they built the distribution function. They published their data sets as histograms. And it took a few weeks to build the support in the PPOTG to create a traffic that follows this distribution. And this is what can be seen, the desired, the target, and the generated at the nanosecond level precision was perfect. This is another use case from nice to have also of a collaborative project, colleagues from different universities, mainly from the Federal of Espiritu Santo, Magnus, and our friends. They are experimenting with this source routing mathematical approach that can be supported by programmable hardware. And the problem that they had was similar to what we had. I only have one Tofino, one switch. How do I build one topology if I have one switch? That was the original motivation of our P7 work, and together with the vision of Mininet. So in a couple of months, it took maybe 2 months to incorporate the code, to solve, to get some extensions and be able to try out their crazy forwarding routing scheme. It's crazy because it's built on very nice mathematical residual Chinese calculation. You put this special number, and then the switch will do a special calculation, calculate the residual, and from there it will know which is the next hop. So it's stateless source routing. So we built this, the proof of concepts, the experiments, even with some slices, and be able to prove ideas. Other more crazy was this idea about drones, which was taking the programmability of P4 and Tofino to an extreme, and using the registers, all the bit space of the memories, to create a map, a two-dimensional map, but could be also 3D, of drones. Drones were sending their locations, okay, and these locations were being captured and parsed and updating this map, and then running some of the centralized collision avoidance that calculates cones and knows the position and directions. It would send messages directly from within the switch to the drone saying, hey, don't go into that direction because there is collision, danger of collision, okay? It's an exercise, okay? But you can see how far you can go into a neat network function at the edge inside the Tofino boxes. And then, of course, playing with delay, what would happen if this centralized decision would be taken within the cloud at the edge, how long it would take. These were the experiments at different speeds. Another example also of combining a simulator like the Coppelia one with our emulator. So it's a experimental, as much as realistic as we try to do. This was earlier where the same was exercised with a robotic arm. These robotic arms are, they have zero brain here. There is a PC, a desktop, or a server that receives everything from the positions of this 7-degree and takes the decision, the path, generates all the commands to the robotic arm. So we put the P4 in the middle, created a zone of danger, and whenever we saw the 3D dimension of any of the angles going, within the same TCP connection, the switch would tell the robotic arm to stop much faster than the cloud would do. Okay? Exercise. And what we are doing these days, literally, is with volumetric streaming, point cloud video streaming, Gaussian splat type of media. It's very demanding in throughput, very sensitive to latency and packet loss. So we have this server, client, headset, Wi-Fi, and now we have the private 5G as well, connectivity that will be inaugurated next week. Next Wednesday will be the big day of smartness 5G. And then the Tofino, again, the P7 will create different paths, different slices, and we can see literally the effect of the network into these demanding applications. Okay, let me spin. I know I have 2 more minutes. These are the setups. These are the Tofino boxes, the MetaQuest, the experience of the user selecting the slice, connecting and seeing this point cloud videos movement, this volumetric video, and the effect of the network. Okay, this is future updates, future directions. No, this is work in progress. Okay, I was literally updating until yesterday what we are doing. So improving performance, scalability, adding in-band telemetry, better models of packet loss and jitter that are more dynamic and not just controller updated or fixed. Moving to SmartNICs, so moving emulation and traffic generation to the SmartNICs, to the blue fields are also, we are doing a lot with SmartNICs these days. Integrating with Open RAN, putting the switch in the front hall and having them generating background traffic or adding emulation segments inside an Open RAN architecture. And there are other very interesting things like emulating conditions of satellites and communications to LEO that have very well-defined patterns, or generating AI type of distributed AI learning workloads, LLMs that are massive inside the data centers. These are other related things. And there are more for sure. Good. Some more messages now back to our template. I was trying to move everybody to the template, but I couldn't make it. And I chose the black one. The Cristiano's white one was much better. Okay, in any case, so reflections, community and impact towards 6G training and education. We need these tools that are flexible, accessible, that help us building labs. Okay, I use them in my lab classes. Mininet is widely used, but there may be more that we can put together as a community. So more open ecosystems for training, education, of course, research, data sets, standardization that is starting. These tools can be useful. All the software-only domain APIs that Cristiano just presented are good opportunities for our software talented students. They don't need the network. They can emulate, abstract, and have realistic events, conditions that trigger all this consumption of APIs. Just find the right abstraction and the right combination of tools. Okay. Okay, so key takeaways. Uncertainty. We know that we don't know how 6G will look like, the protocol. So we are building as a center, as a community, these tools that can adapt to anything or as much as possible. Openness, flexibility, time to test, time to demo, time sensitive is what 6G research needs. We have the programmability assets, SmartNICs, Tofino, DPDKs, ODPs, many good frameworks in place for hardware acceleration, realistic experimentation. And I presented to you the Toolbox with good fidelity towards the unknown, but of course, starting with what we can do right now. So, and that's the message also of Ian, when he said, we will fix in 6G what 5G cannot deliver. What we are doing right now is stressing our 5G standalone network with background, with demanding applications to see the limits, and then hopefully those limits will be overcome in 6G. Okay, everything open source. Have a look at our websites. Follow us in LinkedIn. Trigger the YouTube is not very good, but we'll fix that also. And thanks a lot for the attention.
Questions?
Hey, thank you for the lecture. Can you get back one slide, please, just to pick the QR code with the GitHub, please?
This is
Thank you.
I wish all the questions were like this. Thanks. And just go to Smartness and you will find the GitHub codes. Thanks.
Now a tricky question, right?
Yeah.
Very
Now you
hard
need to
one.
compensate.
Yes, okay.
Well, I know he will compensate.
No, nice question. Are you planning to study or maybe to stress this private network with tokens, communication, tokens packets? Like, ChatGPT and these LLM applications today are the ones that are generating more traffic.
Mm-hmm. So
probably more than video, etc. So I know that in the core network, there is a chance. Also, some companies are trying to push it at RAN level. So that's my question. Are you planning to include it in your test?
That's a nice question. And we started seeing the LLM distributed AI training patterns and so many papers fixing this, that one of the traffic generation features that we want to add is this one. Like you can define some of these LLM type of distributed or tokens you mentioned, type of workloads that are very specific. They have some, they have very specific patterns. So that for sure. The 5G stressing with that, I didn't thought about it. I think this is a good question. So once we have the traffic generator profile, that we can show it is similar to what others are publishing, like we did with this, then we could put the in our 5G network. But at the end, the idea would be to see what the performance limit, the impact, how the 5G conditions impacts this type of traffic, right? So at the end, the question is, we could do it, but what would be the question? We want to see the limits of the 5G in supporting this, or the impact in which dimension? I would love to talk more about this.
Okay, let's thank Professor Cristiano again.
Okay, thank you.
Thank you. Now we are moving to the end of the first day of our workshop, and the closing will be quite nice with Professor Kleber Vieira Cardoso. He is a professor from the Institute of Informatics in Federal University of Goiás. He's an associate professor at the Institute of Informatics at the UFG, where he has been working as a professor and researcher since 2009. He holds the Bachelor in Computer Science from UFG in 1997, and the Master degree 2002 and PhD 2009. All then in Electrical Engineering from COPE, Federal University of Rio de Janeiro. In 2015, he spent his sabbatical at Virginia Tech, USA, and 2020 at Irias-Saclay, France. Professor Kleber has participated in several international research projects, including 2 projects from the BREU joint calls, and has coordinated multiple research and developing projects with national fundings. His research focuses on wireless networks, software-defined networking, virtualization, resource allocation, and performance evaluation. Professor Kleber, welcome. The floor is yours.
Thank you, Luciano, and thanks for the opportunity to participate in this event. Congratulations. It's a very nice workshop. Well, in my talk, I intend to present very briefly some of the works we have done recently related to applications and services that can be enabled by 6G core. Actually, I want to thank my colleagues in this session because they paved the way for this presentation, since they already show us really interesting technology that now I can build upon. Well, my agenda is quite short. I will focus in 3 works. From then, I intend to get some takeaways. The first one is a work that is already done. I will just show the results. The second one is something that we are about to finish. And the last one, as you probably is imagining, something that we are just starting with. As you can realize, all of them are related to resource allocation, and there is a good reason for that. We believe that when we talk about advanced services and applications, the careful allocation of the resource is something that is mandatory. Otherwise, you're not able to satisfy the demands of these applications or services. And there is a second important reason for that, which is the cost effective that these solutions must provide. So before I talk about this work itself, let's just make a very quick review of the context. As Christian already described, we are talking about the core network. And when we think about not only the core, but 6G as a whole, we are expecting more than the traditional evolutions. Of course, we expect speed, we expect more lower latency, we expect more coverage, but we also expect more in terms of support for our advanced services, our advanced or our new applications. And when you talk about these improvements, I'm talking about things like proper support for these applications. I think that Cristiano gave us a good idea of that, talking about Open Gateway, Camera APIs. And we also, when you think about this new support, we are talking about artificial intelligence. I think Christian made us very clear that we don't know what 6G will be, but for sure AI will be there. And we know that we will use AI as a tool inside our network. Maybe a tool is not a good word, as I learned today from Professor Ian. As he said, is a fabric, is something that will be everywhere in our network. And also the network will be support for this artificial intelligence. This kind of application also needs help from the network. And of course, since we are building 6G upon the previous generation, we are inherently from the other ones, things like edge computing, SDN, NFV, network slicing, and so on and so forth. Some of them, I think, has been already well developed. For example, SDN, NFV in 5G is something that we can say that is in a mature stage. But other technologies such as slicing and edge computing, I think will be more leveraged on 6G networks. But it's interesting to realize that the core is in a very well position in order to give us access to all these interesting resources. For example, we can have access to the access networks and all the resources we have there. We have access not only to 3GPP networks, but also to non-3GPP networks. We also have access to the edge resource. This edge resource can be included in the core. And you know that the core is also how we connect to the internet, and where we also have services being provided to the users. So this special position gives us access to a lot of information about the users, the applications, the resource, and also allow us to, in some sense, orchestrate, manage this. And this is something that we must be very attentive about, because we are talking about very expensive resource, and mainly from the operator point of view, we must make the best use of this resource. And a second point also is we are not talking about it to support just a bunch of users of a certain application. In my presentation, I will always talk about scale. We are very interested on achieve scale, because if you're talking about an application being successful, we expect that this application is used for a large number of users. So we are also worried about scales. Well, so now starting with the works itself, we start with this one, where I will explore very briefly the idea of smart tours. The applications about recommendation on itineraries for a user is something not new. There are a lot of works on that, not only in the literature, but even real-world systems that recommend these itineraries. And in this work, the idea is to combine this with applications, not only the traditional applications such as, traditional applications such as social net or video streaming, but also with mobile augmented reality, which is an application that we consider advanced because it depends on resource. For example, a minimal latency, actually a maximum latency, a minimum amount of data rate, and this demands special care from the infrastructure. In the traditional recommendation system, the system use information such as the popularity of the point of interest, the user interest in such categories. For example, we can talk about museums or stadiums or parks, beaches, and things like that. And you also have some constraints. For example, time is an important constraint for a tourist. Well, but in the traditional tourism, the users are not take care or not aware, or they do not have access to this new application. But we expect that it will be very common in the near future, mainly with infrastructure such as 6G. So in this context, well, we can do better if we take care of everything together. That's the point of the work. And another point that I want to highlight here is we are talking about resource allocation, but we are also talking about recommendation. And as we show soon in the results, this brings us a very interesting set of results that shows that when we combine these two, we can end up with some very promising results. Here's a summary of what we can call our system model. So we have the tourist. They provide us information such as the budget, the time budget, or the monetary budget, whatever. They have interested. I will show you in the next slide that in order to provide this, actually, we have a lot of data from these users. This is another central point in this work, and actually in the other that I will show to you, that we need to know how our users use the application, how they use the services. When we are designing technology network, we say that we are worried about this application, that application, because this application, that one demands a lot. But in fact, we are talking about in a very generic way. When we are doing resource allocation, we need to be more pick on that. We need to look with more details because there are a lot of opportunities there, so we can make resource allocation much more cost-effective and much more interesting, even from the point of view of the user, because we are provide him what he or she really needs and not what we think they need. Okay, so we need this information about our users. So this means data sets and things like that. We also collect from these users information about service and application that they have interested. And we put together also information about what they want to visit. So things like the graph, or how the user can move from one point of interest to other, the popularity, the distance, and then a lot of other information. And we also add now, this is that we introduce in our work, the idea of available resource here, communication and computation resource in order to support the application. Now we put these two in what we call our system model, and we have as output the one recommendation for each user, taking into consideration all this input. Here is just a summary of our optimization model. I will not go into detail in the equations, but the idea is to have basically two stages. In the first stage, we focus on try to maximize the profit. The profit here represents mainly the interest in the traditional way of the tourist, but we use multi-objective approach in which we generate on purpose multiple solutions, multiple non-dominated solution, which means Pareto front. And this Pareto front is important because then we will extract from this Pareto front the effective solutions that we are interested. Now take into consideration not only the interest, the traditional interest, but also the resource in terms of communication and computation that is necessary to support the users. And here it's interesting that we want to maximize these. So we want to maximize the experience of the users, take into consideration what they really want, but also take into consideration that the resources are limited, because we're talking about a game of expensive resource. And here, as I said, is just to illustrate how important it is to understand our users. Here, there are information not only about the users that are in these two columns, but also about the places they like to visit and the cities where are these places, and a lot of other information. We did a lot of evaluations and investigations in terms of statistics to understand our data. So is resource allocation, but is very guided by data and data from the users. Here is a summary of the results that I want to highlight what I said in the beginning, which is how interesting it is to combine resource allocation, which just give to us a result that how we can set up our resource in terms of communication and computation, but also open the opportunities to influence, in this case, positively influence the decision of the user, since we are providing recommendations. So here I have results concerning user experience. UI here is not user equipment as traditional in telecom, is user experience. In AE is the allocation efficiency. As highlight here in this red rectangle, we can see the improvements. Sometimes the improvements are very small, they are marginal, but in other scenarios we have again much more interesting. In this is only looking at the allocation fees. When you look at the user efficiency, user space, I'm sorry, we see that we have other gains that are very interesting. Here we have in this part the all lengths of the itinerary. This is related to the data sets. When we deal with real world data sets, we need to deal with the reality. Sometimes these data sets are not the way we would like they should be, but this is important to manage. But we can make some cut on this and say, oh, if I have more appropriate, what would be expected? For example, if I use only itineraries at the size of 3 or more, which is much more interesting in terms of resource allocation, then we see that the gains become even more noticeable, both in terms of allocation efficiency and user experience. So I think this is the main takeaway from the first work, which is combine resource allocation, mainly using contextualized information and recommendation. We can achieve very promising results. This is a comparison with a state-of-the-art work. This is our work has been published this year in the Elsevier Computer Networks, and we compare with state-of-the-art in this work. Now going to this second work, which is actually about to finish. In this one, we are interested on immersive applications. And to be more specifically, VR cloud gaming. Again, at scale, okay? First of all, let's review what is an immersive application. So is a quite demanding application. For example, we need high resolution, we need extreme frame rates, and here we must have attention that this frame rate is a little bit different than the frame rates that we are familiar with in the case of video streaming, because in video streaming you can do a lot of compression a priori, but here we must be must take care of very low demands, because we are talking about video that we must generate and compress or code in real time as the user is moving around, for example, in a virtual world. So we cannot do the compression before. So this limits a lot the compression work, which means that this will create a lot of demand in the network in terms of data rate. Another important thing that we assume that not only today, but mainly in the future, we want to use lightweight HMDs. I want to use a lightweight glass. I don't use a heavy device that gets hotter and hotter as I use, and I must substitute the battery because it's going low. So in order to do that, we need to offload tasks, mainly the have tasks, for example, rendering. Okay. In general, this is what we are saying when we are talking about an immersive applications. This is generally described as a demanding 6G use case. And this demanding use case depends a lot on the network infrastructure in order to provide the user the proper user QoE. And I will develop a little bit more on this QoE. I didn't in the previous work, okay, but now I will go a little bit further on that. And here I have a preview, which is, well, we are interested on motion to photon, which means since the moment that the user make a movement, for example, in his head or in his eye, we have eye tracking. This is quite common in several HMDs, and he can move his hand or other part of the body that is also tracked by the HMD. So I want to send this to game engine in our example, or to other type of server that is on far from the user, and this will be processed, and the impact of what the user did will be sent back. So this is the loop of motion to photon, since the user made the movement until the time that it realized that something happened in the video. And we also must take care of the high resolution extreme FPS, because, as I said, we cannot afford of assume that this will be pre-coded, pre-compressed. We need some time to do this during the interaction of the user. This is the scenario that we are interested. So we have our 6G network with a base station and users that can be moving around. And we have a lot of edge computing spread on our network. These resources can be very close to the user, but probably they are much limited. They can be a little bit far from that, but then we have more resource available, and we need to manage that. What do we have from the side of the user? Well, I have lightweight HMD, as I described it, which will be responsible for decode the video that you receive from the server and display that to the user, and collect information from the sensors and send to the server. The server do the hard lift, do the real work. So it process the inputs, apply the game figs, render the video frames, encode the video frames, and send these video frames. And in the middle of that, I have my infrastructure, which is composed of the wireless part and also eventually a wired part. So I must be careful with the resource allocation in the wireless part, and also in the wired part that will involve routing. And what we are doing in order to be more attentive to the application in this case. As I said here, I would go deeper in this quality of experience, and here is a point on that. We leverage on semantic object segmentation and user attention prediction. Well, with object segmentation, for each frame, we can identify which part of the image that represents something. For example, a person, a tree, a chest, a car, a rock, whatever. And after that, we can identify the attention to a specific user to that image. This part is not only a matter of machine learning, but also depends on data from each user. So here we have a very customized resource or strategy. Here also we have something that is in some sense customized, but it only depends on the content of in this case, the game that the user is experiencing and to where the user is looking at. But this part, no, this part depends on, I know previously how the user play a game, how the user interacts with things inside the game. So with this information now, I can really associate to each object that I segmented before, which is the attention that I need to have to that object. Well, so why I need this? Because I put this in my optimization framework. So from the image segmentation, in each image, I extract a group of virtual objects, and to each object, I assign a weight, which is related to previous information that I have from each user concern his or her interested on each object, the size of the object, the angle that the user is looking at that object, and with that, I can compute a sort of score, and based on that score, I can associate, for example, a higher resolution in order to maximize the QE of the user. The other things that are in the scene, that are in the image, I can use a lower resolution, and then I save resource. So now I'm doing a resource allocation much more fine-tuned than before. And as I said, also we have a special care about the quality of experience from the user. Here is just a summary, and in this equation, we not only capture the resolution and the frame rate of the video, but we are also capture the Weber-Fechner law, which tell us that I have to take a lot of care with the users that are receiving poorer combination of resolution and FPS, but I really must think about if I want to give more resources for a user which already experience a good combination of resolution or FPS, because according to this law, the perceived stimulus, it grows logarithm, as is represented here, with the increment in this stimulus. So stimulus and perceived stimulus, they do not grow linearly, they grow with this logarithmic relationship. So this is again another very important information for us when we are allocating resource. Another I think, takeaway that we have in this problem is that we must take a lot of care with performance, mainly if we are talking about, oops, sorry, if we want to achieve scalability. Okay. This work, what we did is, first of all, decompose the problem into different sub-problems. And in this case, one of them was related to user association long-term throughput. The second one was related to placement of virtualized resource, more specific, the game engine, and routing the content to the user, which means long-term route latency. And the last one related to short-term throughput guided by the users. We are talking here mainly about scheduling PRBs. Just to conclude with this part, what we realize when we compare with another state-of-art solution is noticeable improvement. For example, here in the first stage, when we compare our solution, we achieve better results, even in comparison with dual connectivity. In the routing part, we are achieving a very good performance in terms of cost. And finally, in the last stage, we're able to achieve the total QoE. The higher QoE here is the green one. The red one is only using the traditional optimization. By the way, I forgot to say, but we use some very efficient heuristic in order to achieve scalability also. It's not a matter only to split the problem in different sub-problems, but also to solve them very efficiently. And to finish my presentation, I'll be very quickly about this semantic-oriented resource allocation, which is a work that we are just beginning. Here is the classical comparison between Shannon and semantic communication. I think everyone is familiar because in the Shannon we are just worried about transmitting a bit from the source to the destination, but with no meaning of the bits that are transmitting, while in the semantic communication, since we have a shared knowledge between source and destination, you can use this to make a more efficient extraction of information and transmit that in a semantic way. Well, here we are studying a special case of semantic communication, which is offload of tasks. This is interesting in case where we want to use powerful services, AI services that are available in the edge. And since we have to send data, and sometimes these data are quite heavy, so we'll demand our uplink that can suffer from issues such as low SNR and battery limited device. Here is interesting that we have an end user, but the user here in the network is actually AI elements. So we are in this case, the network is trying to improve performance. When you talk about QoE here, is not actually to the end user, but to the AI elements that are using the network to provide the service to the end user. What we have here among our encoder and decoder is a classic JSCC, is joint source and channel coding, but instead of worry about the final content, which is in this case the picture and the classification of this picture here, what we are coding is the output of tool, AI tool, which is a vision transformer, and we are delivering this to a classifier. In this work, we were interested on an orchestration strategy, optimization approach for this contest, I mean the contest of semantic oriented, and we can deal with things such as this JSCC, which means that we can tune this in order to use more or less resource in order to have more or less data being sent through the network. And in this picture, we illustrate our orchestration in which we select which tasks we want to go through this semantic channel, because some tasks can use a traditional channel because they are not AI related. The point is, when we deal with we tune this JSCC, this joint source channel coding, we are also change accuracy in our application. We are paying an overhead, and we are also change the amount of data. So, of course, we want to optimize this, and we can assign different weights for these aspects and explore that in our optimization. So in summary, we have here what we call, as I said, quality of experience, but our end user here is an AI, not a final human user. And we have here what we are trying to optimize, assign different ways for latency, for energy efficiency, and for accuracy in our application. With some difficulties in these sort of problems, such as having to optimize in a continuous domain. So we use different strategies. Here I have one using a multivariate nonlinear regression. Here I have a different strategy using linear regression. And here we compare them. It's interesting, this we can discuss further this, but it's just to illustrate that probably a lot of people thought that solution A is better because it's nonlinear and try a better approximation, but actually it depends on how you apply that, and we show this. And as we are talking about AI, of course, we depend a lot on data, and we need to use a lot of different strategies from machine learning, such as visual transformer, the joint source and channel coding, and we need to find ways to measure this cost, because AI, as we heard a lot of today, is not it is not a free lunch. It's expensive one, actually, mainly in terms of computing resources. But we end up with some promising results. This, as I said, this is still in the very beginning, but we see, as probably we are already familiar in the literature, with improvements on QoE. But here we are talking about QoE in a semantic scenario. So then I finish. I want to thank you again, and this is it.
We have time for some questions before the close.
You have said that you are interested on QE, but not from final users, but intelligent agents, AI agents. How do you measure the quality of experience of the agents?
Well, actually, this is very related to this previous, the last work, right? And we measure that. Let me come back very quickly here. Using what we have as output here and what we deliver here. Here we are sending an array of probabilities of classification, and then we are delivering to the classifier this, that since we are manipulating this, we can affect the results, right? And then we measure the performance of the classifier. The performance of the classifier will affect the performance of this AI agent. In the end of the day, the user will perceive that. When we say that we are not looking at the user, we are not looking directly to the user, but in some sense, we will feel this impact. But we are measuring this by metrics of the AI agents.
More questions?
Thank you for the presentation. I have one curiosity. Are you modeling any RAN impairment in your studies?
You mean in this semantic oriented? We are modeling a very simple way using AWGN channel. So actually here I shown very briefly, but in the graphics we have here, this is SNR. So here is also SNR. So this is the impairment, we can say that.
If you come back to the previous slide, or in the next one, I guess, in the diagram.
This one? No.
No, in the
This.
one, previous. No, it's the system model, I guess. You were showing. Yeah, this one, that's okay.
This one is okay.
Here, you are proposing this joint source channel coding and also the decoding side. So you are, at some point, you are proposing to not consider LDPC and polar code that are probably
in this
the main
case,
key elements in radio.
Yes. I'm sorry. I think I was very briefly in this part, but when we isolate here, for example, task A, and say that task A will be through this image semantic encoder, I just represent or coding my, no, I think here is better. I send here in my complex representation of the signal directly the information. By the way, this is something very challenging because for us that we are very familiar with applications, they are dealing with transport protocols. Now, no, I'm doing directly. I'm manipulating the signal in the physical layer and send over the complex representation of the signal. I send symbols. Exactly.
Okay. Thank you.
Another question? Okay, so you can thank Professor Kleber once again.
Thank you.
Professor Kleber.